Okay, ladies and gentlemen, we're going to practice a little bit more doing stoichiometry problems with solutions, okay? So I have 200 milliliter solution, so both of them are 200 milliliters of 0.1 molar NaI and 0.1 molar HgCl2, and they're mixed together. I want to know the molecular equation. So I already know what I'm given. I'm given NaI aqueous, and I'm given HgCl2 aqueous. I want to predict the precipitate and balance the equation. So here I go. To predict the precipitate, I know it's a double replacement reaction, so I know Na is going to have to switch its partner, and it's going to be Cl. And I know Hg is going to have to switch its partner, and it's going to be I. And that would be HgI, because I has a negative 1 charge. I has a negative 1 charge. Okay, so now I have to balance. Well, I have 1 Na, 1 Na. 1 I have 2 I's over there, so I'm going to need a 2 there, which also changes the Na. So let me go ahead and change the Na over here. I've got 1 Hg, I've got 2 Cl's and 2 Cl's. So now I have to predict the precipitate. Well, Na is a Na. Okay, it's an alkali metal, so that means it's always soluble, always soluble. So that means it has to be the aqueous solution. Okay, I don't know what's going on with my pen right now, but it's not making me a happy girl. Okay. Okay, so that means that this has to be the solid. Has to be the solid. The only thing left, it could be a solid. So there is the solid. So what is the complete ionic equation? Well, we know the molecular equation. There it is. We just wrote that out. So the complete ionic equation would be that broken apart. So we start writing out. So we have 2 Na plus aqueous plus 2 I minus aqueous plus Hg 2 plus aqueous plus 2 Cl minus aqueous. And then we go to the next side and we have 2 Na plus aqueous plus 2 Cl minus aqueous, and we have HgI2 solid. So there's our complete ionic equation. No big deal. We've done that before. We just break apart all the aqueous substances into ions, and we leave the solid as a solid. Okay, what are the spectator ions? Well, if we look, the spectator ions are the ones that don't change from side to side. They're exactly the same. So we have 2 Na plus aqueous, 2 Na plus aqueous. So that is a spectator. So Na 1 plus aqueous is a spectator. Okay, we have I2 minus. I is in my solid, can't get rid of that. Hg2 plus, Hg is in my solid, can't get rid of that. 2 Cl minus, I've got 2 Cl minus here, I've got 2 Cl minus there. The Cl minus is the other spectator. So, and Cl1 minus aqueous. Those are the spectator ions. So far so good. Nothing new, nothing hard. This is what we practiced on Monday. So some of this is exactly what we practiced on Monday. So now let's see what we can get to. So now what is the net ionic equation? Remember, here's the complete ionic. We know that this and this are spectators, and this are spectators. So what do we have left? Well, we have 2I 1 minus aqueous plus Hg 2 plus aqueous yields HgI2 solid. There is our net ionic equation. And we have to make sure I have 2 minus charges, I have 2 plus charges, that's a total charge of 0. There's no charge over here, so all the charge balances, the mass is balanced because I have 2 I's and 2 I's and 1 Hg and 1 Hg. Everything is good. So that's the first part of the problem that we have to solve. Okay, are we clear so far? So we're going to create, so we want to find the concentrations of each ion in this reaction and the amount of precipitate formed. So in order to do that, we have to remember that a 200 milliliter solution of 0.1 molar NaI and a 200 milliliter solution of HgCl2 plus. Okay, I'm not sure what just happened, but I thought I had another slide in here. I don't see it. So find the concentrations of each ion. Here we go. So what we have to remember is I had 200 milliliters of solution 1 plus 200 milliliters of solution 2. That gives me a total of 400.0 milliliters in the end. So I have this much volume in the end, or 0.400 liters in the end. There should be another 0 there, but that's okay. So that is the volume in the end. Okay? So how are we going to go in solving that? So the two solutions are mixed, therefore before volume of each is in case is 200 milliliters, but after mixing there's 400 total milliliters. The reaction occurs between two ions, therefore we must determine a limiting and an excess reactant. So that's what we're up to next. What is the limiting and excess reactant? So huge, one ion will have a concentration of 0 while the other is partially used. That's pretty important. One ion is going to be completely gone while the other ion is going to have something left. We just have to determine that information. Okay, because the other ion is a spectator. So we're going to develop a scorecard, and notice in the scorecard I have concentrations of all the substances. I have the Na, I have the Cl, I have the Hg, I have the I, and I have the HgI2. And notice it's not a concentration. It's not in concentration bars. So we know that we're not looking for a concentration, instead we're probably looking for a mass. So I start with one compound. Which compound? I'm going to start with the NaI. Pretty simple. Okay, so I start with 0.100 molarity. Okay, so I know I had 0.2000 liters of the NaI solution. And I know that I have 1 liter of NaI solution and 0.001 moles of NaI solution. So when I do that, I end up getting 0.0200 moles of NaI. So that's the number of moles of NaI. That means I have 0.0200 moles of Na, and I have the same of I. I have 0.0200 moles of I. Remember, Na plus and I minus. That is because the formula is 1 Na and 1 I. Pretty simple. Which one of these two was the spectator ion in this situation? The spectator was Na. Na1 plus was the spectator. So all of the Na comes from this part of the reaction, which means I can now determine the concentration of Na, because now I now know 0.0200 moles of Na. And how many liters did I have? I had 0.4000 liters. So I go and do that, and I get 0.0500 molar for the Na. So now I go, after I've determined that, and I've determined the number of moles of each of these things, I go and I put that in there. There's my concentration of Na. Okay? So now I work with the other compound, HgCl2, important. For every 1 mole of HgCl2, we get 1 mole of Hg2 plus and 2 moles of Cl minus. So we start looking at HgCl2. So when I look at HgCl2, I'm going to say, okay, so I have 0.2000 liters of HgCl2. And I know that I have a 0.100 molar, that's moles of HgCl2. Sorry about the line. And 1 liter of HgCl2 solution. That means I know that I have 0.0200 moles of HgCl2. Now reminder, that means I have 0.0200 moles of Hg2 plus, and I have 2 times that amount, or 0.0400 moles of Cl minus. Why is that? Because there's a 2 right here. That 2 tells me I'm going to have double the number of moles of Cl because there are double the number of moles of Cl in the formula. Which one is the spectator ion of Hg and Cl? Well, Cl minus was the spectator. Since Cl minus is the spectator, I can determine the concentration of Cl minus now. I have 0.0400 moles of Cl minus over 0.4000 liters, and that gives me 0.0100 molarity. No, I'm sorry, I made a mistake there. That shouldn't be that number. It should be it should be this number. Okay? Everybody got it? Let me double check and make sure my calculation is right because I'm questioning myself really quick. Yep. Okay. So that's molarity of the, Cl minus. All right, so next, we filled it in on our scorecard. So now we have to do some stoichiometry. Now we have to determine the limiting reagent. This is where we have to look at the reaction. So here's our net ionic reaction, and we need to determine the stoichiometry. So we know that we had 0.0200 moles of I minus, and we have 0.0200 moles of Hg plus, 2 plus. And I know, according to my reaction, it takes 2 moles of iodine, ions, to make 1 mole of Hg2 plus. That means I need 0.0100 moles of Hg2 plus. And if I compare that, I have enough. If I go over here and I do this part, I need 2 moles of iodine ions for every 1 mole of Hg2 plus ions, and I'm going to get 0.0400 moles of iodine. This is my problem. Look at that number. Compare it to this number. I do not have enough iodine, so I have just determining that iodine is my limiting. It is my limiting reagent. So that means Hg, sorry, I can't find my cursor, Hg is my excess. So I can start thinking about this now. So with Hg in excess, which one limits? That's the iodine, okay? So with Hg in excess, what do we know? So let's go back to our problem really quickly. We know we had 0.0200 Hg, and we use 0.0100 Hg. Okay, so let's go over here and write that down. We know that we had 0.0200 moles of Hg2 plus, and we know that we had to use 0.0100 moles of Hg2 plus. That would leave us left over 0.0100 moles of Hg2 plus. Pretty simple, okay? So if we wanted to know the concentration of Hg2 plus, well, 0.0100 moles of Hg2 plus divided by 0.400 liters. Okay, and when I do that, I will get an answer of 0.025 molarity in Hg2 plus. So that's the answer for my molarity of Hg2 plus. So therefore, I is limiting. By definition, we will have 0 I. So I will have a concentration of 0. It runs out. There is no more I. So now we know I is 0. I think I already determined the Hg, and I should have. So we already know it's 0.025 molarity. How do we get there? Once again, we put 0.0200 moles, which is what we were given, minus 0.0100 moles, which is what was used up. We get 0.0100 moles, and we divide that number by 0.4000 liters, and that's how we get the 0.025 molarity. Okay? Questions or comments there? So, new concentration of Hg2 plus, we already know is 0.025 molar. So very good. So now we've put that in there. So now all we have to do is find the amount of precipitate. So we always use the limiting when we're doing the precipitate. So we know what the limiting is. What's the limiting? Oops. We know what the limiting is. We know the limiting is I2, so we start there. 0.0200 moles of I minus. We're going to convert that to 2 moles of I minus, create 1 mole of HgI2. We're just doing a little stoichiometry using a balanced equation. Then we're going to come over here and we're going to calculate the mass of HgI2. When we do that, we get 454.1513 grams of HgI2. It goes on the top because that's what I'm looking for. And 1 mole of HgI2 goes on the bottom. Okay, and so moles of that cancel out, moles of that are gone. And then I do my calculation and I get 4.54 grams of HgI2. And so now that is my answer for how much of that I made. So now we have our scorecard all tallied up. We have all the concentrations, and really all we had to do was try to break down each of our reactants and look and seek what it had. So that should be the end. Oh, stoichiometry wrap up. So write the equations out. Make sure for AP that we get the net ionic equation. You must have the net ionic equation for the AP free response parts. Balance that equation. Find the moles from the original solution. Find what is limiting and use mole ratios to calculate the rest. Then once you're in the moles, get out of the moles. So we go into the mole, we find, that's where number 3 comes in, we find the limiting, we find all of our stuff, we use the mole ratio and get it out of moles. So it's pretty simple when it comes down to it. So I hope that you've enjoyed this and I hope you've learned